Hi guys, welcome to SciStudio Complete Guide series. Today we'll talk about glycogen. So today we'll cover all you need to know about glycogen, from glycogen synthesis to its breakdown, its hormonal regulation and its function. Firstly, some background information about glycogen. Glycogen is a storage molecule for excess glucose. It is a highly branched polymer of glucose residues consisting of 1,4 and 1,6 linkages with glycogenin as its primer, core or catalyst. It is found predominantly in the liver and muscles and exists as a large granules. As you can see from the pictures from the side, glucose go into several pathways from glycolysis, which we have discussed and will be linked in the description below, pentose phosphate pathway, and storage via glycogen synthesis. These two hepatocyte cell slides, glycogen exists as large granules in the liver and muscle cells, as you can see in the picture above. Those dark spots are glycogen granules. Glycogen synthesis, otherwise known as glycogenesis. Glycogenesis starts off with excess glucose in the body, and this is the exact reason why endurance athletes such as marathon runners or triathletes do carbohydrate loading, or carbo-loading for short. They seek to maximize the storage of glycogen in their muscles and liver. Excess glucose is converted to glucose 6-phosphate with hexokinase and is a starting material for glycolysis and the synthesis of glycogen. G6P is converted to G1P with phosphoglucomutase, and G1P is converted to UDP glucose by glucose pyrophosphorylase, and UDP glucose is the glucose donor for glycogenesis. And as mentioned, glycogen is a highly branched polymer and it comprises of straight 1,4 linkages chain and 1,6 branch point at every 8 to 12 glucose residues. This is because branching allows better and tighter packing. Glycogen synthase adds 1,4 linkages or glycogen branching enzyme at 1,6 linkages. So this flow chart shows the overall picture of glycogenesis, starting from glucose converting to G6P by hexokinase, then G1P by phosphoglucomutase, then UDP glucose. With glycogenin acting as the core and primer, glycogen synthase add 1,4 linkages onto it, and glycogen branching enzymes add 1,6 linkages to allow branching of glycogen to take place. The synthesis and the breakdown of glycogen is tightly regulated in the body. Hormonal control is one of the forms of regulation. When blood glucose rises, insulin is released from the pancreatic beta cells. It activates phosphatase, in which activates glycogen synthase. This stimulates glycogen synthesis and results in the decrease of blood glucose, as excess glucose is converted to glycogen. When blood glucose drops, glucagon is released and the action is reversed from insulin. Both insulin and glucagon has effects on glycolysis, which is mentioned in the previous video, therefore further regulating the body blood glucose levels. Glycogen breakdown is also known as glycogenolysis. Glycogenolysis involves around 3 key important enzymes, namely glycogen phosphorylase, glycogen debranching enzyme, and phosphoglucose mutase. Glycogen phosphorylase targets non-reducing 1,4 linkages N to break down the backbone to release glucose 1-phosphate. The second enzyme, glucose debranching enzymes, target 1,6 branch point, thus allowing glycogen phosphorylase to continue to break down and the release of glucose. Phosphoglucomutase converts G1P to G6P to be used in glycolysis. Glycogenolysis takes place in the liver and muscles and has a huge role in fight or flight response and the regulation of blood glucose as mentioned earlier. In the muscle cells, glycogenolysis provides an immediate source of G6P for glycolysis. Thus, athlete uses carbo-loading to their advantage to maximize the amount of glycogen in their body for this exact reason. In the liver cell, glycogen is break down to provide an increase of blood glucose when blood glucose is low, especially in times of fasting or starvation for homeostasis and energy metabolism. And in time like this, gluconeogenesis also takes place, converting non-carbohydrate sources such as lactate, pyruvate, and amino acids into glucose for usage in glycolysis. Gluconeogenesis is also discussed in the previous video and will be linked in the description below. And at this last point comes to the end of this video. After understanding the glycogen synthesis, breakdown, regulation and its function, and how endurance athlete uses carbo loading to their advantage, I hope this video proves useful to you. If you want to see more videos like this, subscribe to SciStudio. Do support us by visiting SciStudio on Patreon. Any amount will help us greatly in our educational journey together to make puzzling science concept fun and relatable to everyday life. Thank you, and see you again.